This is the PSU CS Capstone Project Jamshare. Jamshare allows musicians to perform and record live synchronized MIDI or microphone audio together remotely. Jamshare does this by sending audio from one client to another in subsequent order, where the track is combined and then sent to the next player to hear and play along with. For example, we start with the drummer to lay down the beat. Player 2 hears player 1 and plays along on beat and merges their audio before streaming to player 3, and so on. The final player has the completely combined audio that is shared with everyone and made available for download.
Alrighty everybody, today I've got for you the Jamshare demo. Very excited to show this to you. Put in a lot of hard work as a team. So, just to clarify, Jamshare is a piece of software that allows musicians to remotely make music together. And we have implemented it through a website. So, as long as you have a Firefox browser on any device and a good quality microphone, you can jam. Alright, now I will show you all the features. So, wherever Jamshare is being deployed, I'm running on localhost as a demonstration, but Jamshare will be able to be deployed. And essentially, wherever it is deployed, you'll have the option to make an account right here, and then using that account you can sign in right here. But just for the demo, I'll be continuing as a guest. So let's assume you made an account. Then you were brought to this page. So essentially how Jamshare works is through sessions. Up to 4 players can join a session. If I am the first person creating a session, I would create the session. So I'd click right here, and you get the session ID. You'll want to share this with the other 3 people, or 2, or whatnot, however many people are playing. And then we will join the session. So here I am. This shows all the users currently in, and this is all the audio recordings as the jams go on. Here we have a little chat box. And over here is where the jam will be taking place. So it's no fun jamming with one person, so I'll demonstrate another person joining. Let's say George. And we'll input this session ID, which I've already copied to my clipboard. That's how George will be able to join. And now there's 2 people in here, and we can talk with each other. Demonstrate that. Lovely, so people can talk with each other. Also, the way Jamshare works is essentially in a line. So when player 1 starts playing, their audio is streamed to player 2, and so on and so forth. But it's never routed back. So player 1 only hears themselves as they play through the jam, and vice versa. So essentially player order matters, and that's why it can be changed. So let's say George wants to be player 1. We can switch him. Everyone can switch their player order around, but let's switch it back for now. So let's show how a jam takes place. So I am player 1, so I'm going to start the jam first. Press start the jam. Usually we'll ask you which microphone you'd like to use right here, but I've already set it. So first thing is, this is essentially testing that your local audio is working. So you can unmute this. I have my guitar plugged in, so we should be able to hear my guitar right now. Which we can, which means that we are good to go. So we have clicked start jamming, our local audio is working. Now it's up to George, player 2, to now start jamming. So we press start jamming, and hurrah, we have some extra buttons as well. So if you're the last player of a jam, you have the ability to record the jam, since you get to hear everybody playing. So if I, player 1, am playing, I can start recording the jam. Also, what you're hearing is a remote stream to player 2. So this is acting as in George can hear another player playing. And let's say George likes what he's hearing. He wants to record it. So he presses start recording. Let me play a little. And we stop recording, and we get the audio file saved to our computer. So now George has a recording of the jam, and he can share that with all the other jammers. You can also play the recording. Wonderful. And that is Jamshare in a nutshell. We hope you have enjoyed the demonstration.
Jamshare is a project in which we endeavored to create a platform where musicians are able to play music with each other remotely, with a large focus on accessibility. We assumed that our target audience would be musicians of any level of technical expertise, who will want to be able to play in sync with each other through any common device across long distances without sacrificing audio quality. We have four important features that we focus primarily on: audio streaming, the jam session itself, live looping, and accessibility. For audio streaming, we had to find a way to get audio from A to B. To facilitate this, we used a WebRTC server to transfer audio streams from one player to another. From there, we needed to deal with latency and mixing of the remote and local audio streams. We used Web Audio API to deal with these issues, mixing the audio locally and delaying the remote stream to sync it up with the local stream before sending it to the next player. This ensured that audio quality remained consistent and there was no obvious desync issues. For musicians, they can interact with each other by entering the same jam session by entering a unique session ID. Multiple jam sessions can be served to multiple different groups of musicians this way. This jam session allows musicians to configure settings, such as the order of players, enabling live looping, or starting the jam. When a jam ends, users will be able to download an audio file containing every player's audio. If live looping is enabled, starting a new jam will also play back the previous jam's audio, allowing you to play in time with your previous jam. We worked hard to make sure that the Jamshare experience was as accessible as possible for as many people as possible. Jamshare is available to any device that has a Firefox browser and a microphone. We took steps to ensure that audio quality is impacted as little as possible by the performance or network speeds of the users. We also assume that our users will want to be able to jam quickly without worrying too much about setup, so we prioritize making Jamshare easy to use, allowing users to simply join a session and jam.
We were able to implement some additional features to make the user experience a little bit more enjoyable. We made a user session list, which is a user list users in the current session. We made the list organizable by dragging and dropping, and the list is shared between all users. If this list changes for one user, it will be updated on all users. In addition to that, we also implemented session chat. Um, a session chat is just a session live chat for multiple uses. It's a simple interaction. People can just chat with each other. They can use this chat to just write lyrics or anything or any notes or anything in this chat. We just thought it was a cool feature and we implemented it. And the chat has a chat history, has a unique user customization, all that good stuff. And in addition to that, we also implemented shareable session IDs and a sign up and a sign in feature to create user accounts to keep user customization saved and user recording saved. For future features, we're trying to implement user profiles by making a user be able to use their profile picture, number of minutes jammed, maybe a video jam session, enhanced security for user data. That is an important friend list, important thing we didn't we were trying to implement as and search efficiency optimization. If you ever want to make our site go live, that's a very important thing we should focus on. And during our development process, we dropped support for Google Chrome and we one added backup. And lastly, a sign out feature. Thank you.
This is the architecture and design for Jamshare. So when making architectural decisions for Jamshare, we had a goal of creating sort of an extensible product, which could continue to be built beyond our initial release. For this reason, we settled on a React.js and Express stack, which would kind of facilitate support not only for the browser app which we developed, but in the future iOS apps, Android apps, desktop apps, anything like that is possible with React, which was very appealing to us. There are 5 important layers to the architectural decisions we made here. We have React as our front end, Express for our back end, Socket.io to manage user sessions, Postgres for our database, and Ant Media as our audio server. So React was used for our front end. It's an extensible JavaScript framework used to build views, manage audio streaming, interact with APIs. It also contains a lot of user experience considerations. We dropped our sign-up page using React, our join page, all of the room, pardon me, the room view you saw earlier, all of that was developed using our front end, and it's been really great for that purpose. On top of that, it also allows us to easily handle making requests to our server, which, given that we were using 2 different types of APIs in our authentication system and socket.io. That was very, very convenient. So to build onto that, we used Express as our backend. Express is very often coupled with React. It's a very lightweight server, which simplifies deployment logic and HTTP request logic, which would be much more tedious had we not used the framework. It also routes Axios and socket.io requests coming from React. That's very convenient in that sense. And as a kind of added benefit, guarantees separation of concern between the front and back end implementations here. We use socket.io as our session manager. It's classic. Essentially, Socket receives and handles user requests originating from React. It facilitates dynamic sessions by maintaining a map of user states, which are built from these user interactions. If someone wants to join a session, for example, that will be modified using this mapping system. And for a database, we're using Postgres, another classic here. Basically, it's just handling all of our persistent user data. It's currently used to manage authentication, but it's extensible to bios, profile pics, friends lists, and more stuff like that. And finally, we have the audio server. Our implementation uses Ant Media, which is doing a ton of heavy lifting as far as our audio streaming concerns are concerned. It's a low latency server, facilitates really low latency and real-time connections in large numbers. And basically what we're able to do with this is have our users all be connected to each other in a room such that they can quickly drop audio samples, what we call jams or whatnot, and have the other users be able to access those immediately with very low latency and kind of very little concern for potential quality issues.
For the development process, we followed an agile development process. We met every week, 2 times a week, and kept in communication through text chat daily. The beginning stages of the development process had us splitting up into 2 different teams, the front and back end, where we would work on our respective roles. As the project progressed, the gap between the front and back end began to close, and we began working in conjunction with each other and incrementally merging features into new branches as they were developed for each sprint. The major steps included a lot of research into the technologies we would be using, as well as building up the front-end React components and implementing audio, recording, and signaling communications between clients for the back-end. We split up the work by who wanted to work on each particular area. For the front-end, the process began with the planning of each page and its components and functionality that would go into each page. Then we would move into the implementation with the inclusion of CSS to style each page. The research portion took up the entire first quarter, and the audio part had the most changes throughout the development process of the second quarter. The actual audio streaming was moved to the front end to reduce complexity of communications and is how Ant Media Server worked natively with the Web Audio API. The final step was merging the logic for audio buffers and streams from the Ant Media Server. There were unexpected challenges in every aspect of the project as we were all fairly new to the technology stacks we were working with.
The following contributions were made by each member of the Jamshare team. Zach was our team lead and contributed to the Signal Server Session Manager, acted as code reviewer, managed the team's GitHub contributions, and acted as Scrum Master for this project. Our front-end team consisted of Casey, Jihui, and myself. Casey was responsible for the join sessions component, cross-component communication, and video editing for this presentation. I was responsible for the sign-up page integration, styling of the sign-up and join pages, and created the front-end design and mockups for this project. Jihui was responsible for the front-end styling of the room page, React room component organization, and asset creation. Our back-end team consisted of Morgan, Nicholas, Devon, and Badeed. Morgan was responsible for the deployment and hosting of this project, as well as the user base and profiles. Nicholas was responsible for the Web Audio API, backend buffer and mixing, and the Sessions Manager. Devon was responsible for the Ant Media server streaming and latency and server hosting capabilities. Finally, Badeed was responsible for the chat component, backup SFU implementation, and React app initialization. We also wanted to give a special recognition to Morgan, Nick, Devon, and Badeed for going above and beyond on the back-end team and for putting so much time and effort into building this project. There were a few unexpected events that the Jamshare team faced throughout this project. At the moment, our web audio API is only compatible with Firefox. However, we hope to solve this issue to allow for functionality across browsers. Next, asynchronous functions are required in the instantiation of audio handling objects. So the order that the users start to listen to the publish matters. This was an unexpected issue that has not yet been fixed. Another unexpected event was the requirement of a delay between writing the new incoming stream to the combined buffer on Player 2's client so that the audio that Player 2 provides is written at the same time. This event was addressed using a delay node. And finally, the Webpack configuration was not being used by this project, so we addressed it by using the React Webpack Krakow.
Hello, I'm Jihui. I will now play you with sponsor Dave's feedback.
Jamshare is an interactive musical experience. It enables a live jam session over a network. It's a bit of a challenging network streaming problem, but the Jamshare team took it on fearlessly. Maybe too fearlessly. To be honest, the project was a roller coaster ride. By the end of the first quarter, some basic architectural questions remained unasked. But by the final week, I was thrilled to participate in a working jam session, and it was actually quite fun.
Thank you, Dave. Now I will go over some of the lessons each person learned while working on this project. But the lessons learned is about web development at larger scale, working with a team, front-end and back-end connections. Casey's lessons learned is about communication as a team, and scoping out the right technology is key. Cristina, her lessons learned is about communication across a larger team, integrating back-end and front-end components of an application. Devon's lessons learned is about working on a deadline, web development, integrating code with others efficiently. Morgan's lessons learned is about experience working as a large group on an ambiguous project, the power of friendship. Nicholas, his lessons learned is about start prototyping early, smoothly integrating code with other members, the importance of good documentation. My lessons learned is about make a thorough plan before each sprint can avoid major change. Zach, our team leader, his lessons learned is about experience documenting progress, box hurdles, synchronizing user experience, prioritizing project features and resources.
The Jamshare development team sends our gratitude and thanks to our sponsor, Dave Howell. We also extend our appreciation to the Capstone professor, Bruce Irvin. We hold your guidance to our experience on the journey of product development in high esteem for the lessons we learned. Thank you.